Good day, guys. Welcome to our class for today. We are still continuing with solving problems on motion. So for our class for today, we'll see some more problems on rectilinear motion using the three equations of motion. So guys, if you are new to this channel, this is Nobleman's Tutors Online, and we are presenting video classes to you. We are bringing video lectures to you, to your very home and to your very doorstep. So if you have not subscribed to this channel, please subscribe to our channel, click on the subscribe button and the notification button so that when we upload a new video, YouTube will notify you. And also we will also encourage you to invite your friends so that they can come and enjoy this physics lecture online. Also put your comment on the comment section below. You can also reach us on the WhatsApp number that is showing on your screen. So if you have any problems in physics calculations, you can just reach us with your problem. We will assist you to solve the problem and to explain to you in details how to apply some principles concerning such problems. So for today, we will still continue with our calculations in physics or calculations in motion, calculations using the three equations of motion. So let's go straight to our class for today. Okay, so as I said, we are solving more problems on uniformly accelerated motion using the three equations of motion. So look at this problem. A body which is uniformly retarded comes to rest in 5 seconds after traveling a distance of 10 meters. What is its initial velocity? Now if you look at this question, you are given time 5 seconds and distance traveled 10 meters. So initial velocity is not given to you, and final velocity for a body that's coming to rest equals to 0. So having known that, you can just put the information that you are given from this particular question, that t is given to you to be 5 seconds. T is 5 seconds. Then you also have your distance s is given to you to be 10 meters. Okay, that's the distance that is given to you. Then since the body came to rest, v is equals to 0. That's clear. Then your initial velocity is unknown, which is what you are looking for. Okay, so for you to find the initial velocity, first of all, you find the retardation, right? Because the body is said the body is uniformly retarded, so you find the retardation. So how do you get retardation? You are going to use the first equation of motion, which says that v is equals to u plus at plus at. Okay, so if you make a the subject of the formula, you have that you are going to have that e, or just put it at 0, is equals to u plus at. Okay, so you have that a will be equals to 0 minus u all over t, right? So if you substitute into this formula, the figure that you are given, you have this will be equal to now minus u all over 5. Don't forget that this retardation, so you have a minus sign. So this gives you the retardation of this body. Now, having known the retardation, you know the distance that is traveled, you can actually find your initial velocity, since you know that v is equals to 0 because the body came to rest. So the equation that you're going to use to solve for that will now be the third equation of motion. Okay, so the third equation of motion, you use that. Third equation of motion says that v squared is equal to what? U squared plus 2as. Okay, so substitute the formations you have here, the figures you have there. You have this 0 squared equals to u squared plus 2 times minus u over 5 times the distance, which is 10. Okay, so this is what is given to you. You can actually work this out. So you have 0 squared is equals to u squared minus 20u all over 5 minus 20u all over 5. Okay, so you can rewrite this equation to look like this. It becomes u squared is equals to 20u all over 5. Okay, so this can actually cancel, so that will be equals to 4u. So this gives you that u squared is equals to 4u. Now you can, for you to have your u, you divide both sides by u. So if you divide both sides of this equation by u, you are going to have this. Okay, so this will cancel out, then this can cancel, and then you have just one u here, right? So this gives you that u is equals to 4 meters per second. So this is your initial velocity for this body that undergoes this uniform retardation. So this is your initial velocity. So if you look at this problem and you see how we went about solving it, you know the equation to use for you to get your retardation. From there, know the equation to use for you to get your initial velocity. So hope this is a little bit simple, and when you see any problems like this, you should be able to solve it. Alright, so we're going to solve another problems too, to still drive home the point of using the equations of motion. Right? Okay, so this is another problem that we need to solve. This one states that a body moving with a velocity of 3 meters per second is brought to rest by a constant force after traveling a distance of 15 meters. Calculate the retardation. So if you look at this question, you are given initial velocity to be 3 meters per second, right? And the body is brought to rest by a constant force after traveling a distance of 15 meters. So if you have a question where you have initial velocity that is given to you, and you also have distance traveled, and then you are now asked to find retardation, which of the equations of motion will you apply? It is obvious that it is the third equation of motion that you are going to apply. So now you bring out what is given to you. You are given that u is equal to 3 meters per second. You are given distance to be 15 meters. Give me distance to be 15 meters. Okay, so since the body is brought to rest, your v is equals to 0. Okay, so now you are looking for a, which is the retardation, right? This is what you are looking for. So the third equation of motion states that v squared is equal to u squared plus 2as. So this is the third equation of motion. Now, from the figure that you have, just substitute them into this equation. if you substitute into this equation, you are going to have that 0 squared is equals to 3 squared plus 2 times a times what? Times 15. Times 15. Right? So this gives you 0 squared minus 3 squared is equals to 30. Equals to 30a. Is equals to 30a. So you have that 0 squared minus 9 is equals to 30a. Is equals to 30a. So now you can make your a the subject. You can make your a the subject of this formula. So your a will now give you, a will now be equals to minus 9 all over 30. Don't forget that you are looking for retardation, so that minus sign is there. So if you divide this out, you are going to have minus 0.3 meters per second squared. So this is the retardation for this particular motion. This is retardation. So this is how you apply these equations of motion. That okay? So I hope this is clear, and this is also relatively simple too for you to apply. Don't forget that at the end of this class, I'll be giving you your test, your understanding. I want you to solve all those problems, because the more problems you solve, the more you will understand the topic that is being treated. So please don't shy away. Solve all the problems as you see them. Alright, so we have more equations that we're also going to solve. We are going to the next set, so please let's continue. Okay, so this is another problem. This is another problem that we need to look at. This one says that a car starts from rest and moves with a uniform acceleration of 10 meters per second square for 10 seconds. The distance it covers in the last 1 second of motion is what? It's a jam question. So you need to look at this question very closely so that you know, one, which of the equations to apply or to use to solve it. Then two, how to apply the equation, because here they are asking you to find the distance traveled in the last 1 second of motion, and you are given that the body accelerated for 10 seconds. So the last 1 second of motion means it is the second between the 9th second and the 10th second. Because if the body accelerated for 10 seconds, then the last second, the distance traveled in the last 1 second is the distance between the 9th second and the 10th second. So how do we go about solving this? Okay, so that's what we're going to treat now. Okay, so here you are given that acceleration is equal to 10 meters per second squared. 10 meters per second squared. Sorry about that. Then you're also giving time t to be equals to 10 seconds, right? So if you are giving this, you have acceleration, you have time, and they said the body started from rest, so which means that initial velocity is equals to 0, right? So for this particular case, u is equals to 0. Now, which of the equations of motion can relate this variable that you have acceleration, time, and initial velocity. It is the second equation of motion. So if we apply that equation, we'll have that the equation says that S, because you are looking for distance, S equals to ut plus half at squared. This is a statement of the second equation of motion. Now, how do we solve for this last 1 second of motion? As I said before, the last 1 second of motion, the distance between the last 1 second of motion is the distance between the 10th second and the 9th second. So in this case, which means I will have two times that we're going to use. We are going to use time. We are going to use time for 10 seconds, and we are going to also use time for the 9th seconds, t10, and then t for the 9 seconds. Okay, so which means this equation now you are going to write it like this, that S equals to ut plus half a bracket t10, right, bracket t10 t10 squared minus time of 9 seconds squared. Okay, so this is how you write this equation of motion. Now you know that since initial velocity is equal to 0, this will be equal to 0, this will be equal to 0, that will be equal to 0. So if you now solve this out, you're going to have that S, which is the distance you are looking for, S will be equal to half times your acceleration, which is 10, times all brackets the time for 10 seconds squared minus 9 squared. So if you work that out, you still have, this can actually cancel this out, right? So that gives you 5 brackets. 10 raised to the power 2 is 100. So that gives you 100. 9 squared is 81 minus 81. Okay, so work that out. You are going to have that you will have 5 multiplied 19. If you subtract 81 from 100, you have 19. Okay, so when you multiply 5 times 19, your answer will now be what? 95 meters. So this gives you the distance traveled by this car. That's okay. So if you look at this particular problem, you see that you have to do a little bit of calculations here, and you need that understanding, because you are looking at the distance within the last 1 second. Please try and get that understanding. You are looking at the distance within the last 1 second, and that distance, because the car uses 10 seconds, it means the distance between the 10th second and the 9th seconds. So I hope you understand this. And another way you can solve this problem too is that you can actually find the time for the 10 seconds. Find the distance for the 10 seconds, then find the distance for the 9 seconds, then find the difference. The difference will give you the distance covered within the last 1 second. So you can do that. You can do that. Yes. You can find the distance for the 10 second, find distance for the 9 second, find their difference to also give you the same answer. But this is the shortest method to solve this problem, especially if you had this type of question in JAM. You should know the shortest method to solve your problems for you to arrive at your answer quickly. So I hope you understand this, and then we'll try to solve one more problem on this too, so that you get a more better understanding too. So this is another question. This one says that a body starts from rest and moves with uniform acceleration of 6 meters per second square. What distance does it cover in the 10th second? So if you look at this question, it is similar to this first one that we solved, right? Say what distance does it cover in the 3rd second? In the 3rd second. So which means that the distance it covers is almost like this first question we solved. The distance it covers in the 3rd second is the distance between the 3rd second and the 2nd second, right? The distance between time 3 and time 2. Okay, so just similarly like the way we saw the first one, this one you are giving acceleration to be a is equals to 6 meters per second squared, right? And you initial velocity is not given to you, but it's since the body came to rest or started from rest, initial velocity equals to 0. Fine. Then you are looking at time for 3 seconds, time for the 3rd second, 3 seconds, and then time for the 2nd second, that is time 2, right, which is 2 seconds. So if you look at these two equations, this first one and this one, they are almost like the same. So just the way we solved it, that's how we're also going to solve this one. Is that okay? The way we solved this, that's how we'll solve this too. Okay, so applying the second equation of motion, we have that S equals to ut plus half at. Okay, so this I want to have, I'll go straight to 3 squared, 3 times 3 squared, minus time 2 squared, times 2 squared. Okay, alright, so we know that since initial velocity is 0, this will be equals to 0. That will be equals to 0. So we now have S equals to half, acceleration is equals to 6, so half 6 times 3 squared is to be 3 squared, because that's the 3rd second, minus what? 2 squared, which is the 2nd second. Okay, if you work this out, you have that 3, 6 divided by 2 is 3, brackets 9 minus 4. Okay, so that gives you 3 bracket 5. Okay, so when you multiply that out, you are going to have what? You will be having 15 meters as your final distance traveled by this car. So you can see from here that once you are able to understand this one will be easy for you to solve. So whenever you see any problem like this, please, this is how to approach it. You can actually solve for the 3rd second, solve for the 2nd second, then subtract the distances. You will still have the same answer. So you can try any of the other method. Between this and this, you will have the same answers. I hope this is clear, and I'm sure that we have been able to cover this topic very well. So please, you need to now do your own test your understanding, and that is the next stage that we're going into. Okay guys, so this is your test your understanding page. Please don't skip this. Solve all these problems, solve them, put your answer on the comment section or add up my WhatsApp number and put your answers there. Just go the topic, then put your answers there. I will look at all the answers and then I will give my own response to the solution that you are giving. Better still, solve them in a paper, snap it and put it on my WhatsApp. I will look at the way you solve them, then I will also give my own suggestions. If there are any corrections for me to make, I will make the corrections and also give my suggestions. So thank you guys so much for this class. We are through with everything that has to do with rectilinear motion. So please, thank you, and you are welcome to our other classes. So please, if you are not subscribed to this channel, subscribe to the channel and also invite your guys to join in this wonderful learning experience. Okay guys, so if you are not subscribed, please click on the notification button, click on the bell so that when we load a new video, YouTube will notify you. If you love what we are doing, please give us a thumbs up, and also you can give us a like, give us a thumbs up. Also tell your friends and colleagues so that they can come and join this wonderful learning physics video or physics lecture. So thanks a lot. We appreciate you so much. We want you to please continue to be with us. So we are going to see you in our next class. Thanks.